Hello friends, welcome to our channel Mechanical Motivator. In this channel, we would be seeing mechanical and motivational videos. So today in this video, we would be seeing the stress strain graph for ductile and brittle materials. So in this graph, we will be seeing stress strain relationship for a ductile material. The y-axis will be denoting the stress value and x-axis will be denoting strain value. When we look at this graph, there are various points. So from point O to A, it's actually an inclined line. It is not a curve. Here we are getting a linear relationship between stress and strain. So O to A or OA is called as proportional limit. It means when we keep on increasing the stress value, the strain value will also be increasing. So according to Hooke's law, within the elastic limit, the stress directly proportional to strain. So sigma directly proportional to small e. So in order to remove the proportionality constant, we are going to introduce a constant called as Young's modulus. So sigma will be equal to E, capital E and then small e. So capital E will be denoting the Young's modulus or modulus of elasticity, which is nothing but having a unit of Newton per millimeter square, and small e will be denoting this strain value, which has no unit. So when we are increasing the value of stress and it reaches a point A vertically, that is vertically we get corresponding value for strain. So in this case, if we remove the load, then the stress becomes zero and the object returns back to its original position. The object will be returning back to its original position. It means that the material behaves in a elastic manner. So next we will be seeing A to B, the region between A to B. So the A to B is also actually a elastic limit. So A to B is actually a curve. So A to B, it is a curve and it is not an linear inclined line. So O to A, we can relate the stress and strain relationship. It's a linear relationship. Whereas when the material reaches the point B, what happens is once the material, I mean, once the load is removed, since it's within the elastic limit, it regain its original shape. So now we'll be going to point B. So the relationship will be between point distance between B and C. So actually point B is called as a upper yield stress point. So point B, actually what happens here is the yielding gets started. So the material the material has started going to change its shape. So when the material crosses the point B, then it reaches the region between B and C. So the material now is permanently deformed. So even if we remove the load from point C, then the material won't be regaining its original shape. It means that the point at point C, the material is deformed permanently. So B to C is a region, it is called as permanent set. So now we'll be seeing, and also the point C, actually the point C is also called as lower yield stress point. So the strain will be at this point C, the strain will be more at the point C when compared to point B. So strain value will be greater at the point C when compared to point B. Then now we'll be seeing once the material reaches between the regions C to D. So C to D, what happens is the stress, actually the stress is increasing in a tremendously high manner. So stress at this point, it is the highest point in this graph. So if you look at this graph, means the point D is the highest point, and here we will be getting maximum stress value. So if you plot the graph horizontally, means we will be getting a stress value and that will be the maximum value. So point D, actually point D is called as ultimate stress value. So ultimate stress point D is called as ultimate stress point, and stress will be maximum and it is the ultimate stress. So up to point D, what happens is up to point D, the stress will be maximum. And if we go beyond the point D, the stress decreases. And at a particular point, failure occurs. So now we'll be seeing that the point D will be maximum, and if the material goes beyond the point D and at a particular point E, the material gets failed. Now we'll be seeing distance between, I mean region between D and E. So D to E, the stress decreases, but strain increases. So region between this region, the stress value decreases, but the strain value increases. So finally at point E, what happens is the material will be breaking, and it is called as breaking point. It is very much clear from this graph. So at a particular point E, the material breaks, and it's very much clear from this graph. So for ductile materials, the flow will be like in this manner. It shows the strain variation. So strain is nothing but the physical deformation which we can see, and we can see the material flowing, and finally the material breaks. So this breaking point is just after the material has reached its maximum stress value. So once the material has reached the maximum stress value, then after that, a particular point, at a point E, the material breaks. So now we can say that if the material, that is same thing, once reached the maximum stress value, we can say that at any point, not only at D, it can break here also. So at any point, the material can break. So now we'll be seeing another example of stress strain graph for a brittle material. So same as y-axis is stress and x-axis is strain. So what happens here is in this region, actually this region, it's almost approximately, this region is approximately a proportional limit. The proportional limit means the stress directly proportional to strain. But in brittle material, the behavior is such a way that we cannot say the stress will be directly proportional to strain. So we cannot say that if stress increases, the strain can increase or cannot increase. We can't predict that. So when we cross this particular region, what happens is the stress will be increasing, and along the as well as the strain will also be increasing. Once the stress will be increasing, the strain will also be increasing, and in this region, the strain and the stress and strain will be keep on increasing, both increases. So suddenly what happens is at a particular point the material gets failed, that is the material gets breaks. So this is called as breaking point or fracture. So in case of ductile material, actually in ductile material what happens is before breaking the material gives some warning, that is the material was elongated and its diameter would be reduced, and finally only it will fail. But whereas in case of brittle material, the material fails suddenly. So this is the important difference between brittle and ductile materials. So in brittle material, what happens is brittle material actually here we have internal cracks. Brittle material develops here. What happens is the brittle material develops internal cracks first, which are not developed from outside, and the crack reaches up to the surface. So this is what happening in brittle material. So example we can take many examples we can take. So like wood, concrete, glass, cast iron. Actually, all these they behave in this manner. So these are the brittle materials. So what happens is from outside, any deformation or change in the shape does not occur, but inside cracks will be developed. Actually, when we are seeing from outside, we won't be seeing any deformation or change in shape. But actually, what happens is inside the material, that there will be cracks will be developed. So if I am keep on applying load, the cracks which developed inside the material, so cracks will generate from internal to external surface, and finally the material breaks. So this is the main difference and basic difference between ductile material and brittle material. I hope you would have understood, or you would have had a clear understanding between ductile and brittle material after seeing this video. In case if you are having any doubt means, just write in the comment section. And if you also want to know about any other topic or any other subject means, you can also write on the comment section, so that in future or upcoming days I will be putting more videos on those. Please do subscribe to my channel Mechanical Motivator and press the bell icon. So then only you can be viewing all the videos which I upload. Thanks for watching this video. Have a great day.